Hello, my name is Jutta Steiner. I'm involved with Ethereum, where I'm overseeing the security audit prior to launch. So we took a quite serious approach to the full launch plan. So we have external auditors looking at the code base. So that's what I'm overseeing. I'm also involved with a startup where I'm the co-founder. That's called Provenance. Based in London, where we try to use Ethereum's technology to make supply chains more transparent, tracking transactions, certificates, whatever happened in a supply chain to inform customer decisions and to help them make better purchases, which I think is kind of a really interesting application, given like many people have tried to make supply chains more transparent, and it's basically not possible to operate a system that's run by a third party.
My name's Andrew Colosimo. I am a Namecoin contributor and the founder of Huntercoin, which is a project which incorporates a mini universe within inside the blockchain. I'm also set up a startup company, Crypto Realities Limited, which is going to sort of proceed with making services for games inside the blockchain.
I'm Peter Todd. I'm involved with Bitcoin core development, and then I also do consulting around Bitcoin, blockchain, consensus, and so on.
I'm Dr. Nicolas Courtois from University College London. I run UCL Bitcoin and cryptocurrency seminar. I have graduated about 20 students who did their thesis on cryptocurrency. I'm a code breaker. I can recover quite a few private keys of different people on Bitcoin blockchain. And I'm a security expert in general, especially in smart cards and hardware security.
I am Henning Dietrich. I'm a senior programmer at IBM. And I'm involved in the ADAPT project, where IBM is researching IoT with blockchain. And it's important to add that everything I'm saying here is my personal opinion.
Hi, I'm Vlad Zamfir. I'm a researcher involved with the Ethereum project. I'm working on proof-of-stake protocols, blockchain scaling, reputation systems, and other loose ends.
Casey Coleman, I'm the CEO of Eris.
So we just heard a very long conversation just talking about the number of different blockchains. But there's a pretty intense debate right now about whether or not all these other projects are actually necessary, and whether the real thing that matters here is just one blockchain. It's the Bitcoin blockchain, and that will basically be the rail for all of the distributed and decentralized consensus services and projects that we think are going to be developed. I'm just curious, just because we have a number of the developers of the subsequent or of these other blockchain-based projects. What's your impression? Do you think that is that the direction that it's going? Is everything going to get rooted into a Bitcoin blockchain, or are we going to kind of see kind of a constellation of various blockchains that are being served for different purposes?
Well, I think you got to go ask what exactly is the role of the blockchains and what are they trying to prevent from happening. They are security software, so you're always asking the question, well, what are we trying to not make happen, as opposed to normal software where it's about what are we trying to enable. And I think what the Bitcoin blockchain can go and provide is this very niche, very focused prevention of coming out of consensus. Now, that's not to say that a private blockchain with signers, say 5 different banks who are working within each other, may not want to use that method, but rather, if they're going to do that, they now have a consensus, and then they can double check that consensus against a Bitcoin blockchain just to go prove that there is one consensus among each other, to provide that additional check that even if they all got hacked, even if everything goes wrong, you're still going to detect a lack of consensus. And that's something I think is very appropriate for Bitcoin, but it's a niche thing. It's a layer on top of other systems.
So if you also then think of other applications, like originally the Ethereum project was motivated by the frustration that you can actually only have this kind of niche solution for financial transactions. So Vitalik, who was one of the co-founders of the Ethereum project, was frustrated that it's so hard to build a derivative contract into the Bitcoin blockchain. So like, for example, if you then look at supply chains and you want to track assets, service assets, whatever, it would be really hard to do that on the Bitcoin blockchain.
Yeah, so So we just talked about basically smart contracts. So I mean, what types of things are you seeing being developed with smart contracts, right now, and kind of let's just imagine a world 5 or 10 years down the line. What types of future applications do you think will be used, kind of with a smart contracting platform?
I guess we're going to see like a lot of things initially around that provide more efficient solutions. So, I mean, in supply chains, I guess that's interesting because, as I said, like there's so much trust involved in knowing where things came from. I think this is gonna be like an important thing to revolutionize, like how people coordinated problems in supply chains and collaborated.
I think one of the issues with actually deploying a lot of this stuff is, in comparison to existing solutions work really well if everyone's honest. And being security software, it really comes into play when people are dishonest. And in many cases, that's not actually the case, and there is enough honesty going around that there may be less push to actually deploy these solutions than I think people in the crypto space expect. Precisely because when you go to an environment where there is honesty by default, where the fraud rates are reasonably low, you can go have people look at the cost of these new solutions, these new IT technologies, and say, well, why are we bothering with this? And that's going to be a big hurdle, I think, going forward that will slow adoption.
So, I mean, that's a good point. Do you think, that blockchain technology really provides an economic value in areas where there is a lot of distrust? I mean, in areas where parties can't trust one another, that's really where a blockchain comes into play. And maybe that's why, Bitcoin has been one of the first real use cases for this, because in payments, there's just so many different parties that are involved. They know that it would be great to work together, but there's such a strong amount of distrust between the parties that they can never fully coordinate. But is that a good guiding principle?
Yeah, no, I think that's absolutely true. And the critical thing with payments is fraud is heavily incentivized. If I can go and commit payments fraud, I get money. Whereas in other cases, such as supply chains, certainly in some types of supply chains, there's incredible incentives for fraud. In other types of supply chains, there aren't. And again, this is one of these things where it limits adoption.
So, I mean, Henrik, talking about IBM, is that one of the reasons that's kind of animating Adept and their interest in the blockchain is also this kind of scenario where there is a lot of distrust in order to kind of coordinate internet-enabled devices?
Well, the thing is that, actually, it's no joke. I cannot talk about Adept.
Oh, so I rescind the question.
We talked about this yesterday.
So I'll make the assertion that that may be one of the reasons why you guys are interested in it.
Yeah, so regarding distrust and the first question as well, I would like to add that from the security engineering point of view, it's absolutely obvious the security of different blockchains can be combined, and any of them can provide digital notary services to others, so therefore can get the best security or even best than the best of this blockchain. So basically, you can push distrust even to the point where you would distrust one whole blockchain, and you can still build some good solutions with some extra engineering.
And I should point out, like when we actually talk about security, what it really often boils down to is I want a piece of software to go tell me something went wrong. And if the thing that went wrong is that there are records that exist that are inconsistent, the moment you start putting those records on more different systems in ways that can be cross-audited, that's just a simple combining factor of security. This is not something actually very magical, something very simple, which is I want to be sure that if someone has a record that's inconsistent, somehow I will find out about the existence of that record. And then I can write software that will do this for me. Bitcoin just happens to be a very, very robust way of doing that under certain assumptions. Equally, publishing a summary of your record in the New York Times in some cases could be a very robust solution. Doing both is even more robust.
Yeah, one thing I'd like to add to follow on to what Peter said is that I hate the word trustless, particularly in the context of blockchains and distributed system, because I think that trustless, number one, is an imprecise word, and number two, I think it leads to a little bit of negative expectation. Not negative, but false expectations. But the real key to this technology for me is that it really increases all the network's ability to verify that something took place. Either that was a logical compute action in the context of smart contracts or in the context of a token transfer, it's a transfer of title. So in general, most blockchain systems boil down to increasing our ability to verify either a compute cycle or a transfer of title.
And so, like, to put a precise definition on what we mean when we say trustless, what we mean is we trust that someone didn't spend more than this amount of money to attack this thing. So it is definitely trust, but it's trust in an absence of economic loss.
I mean, there's more than that. I mean, there's also trust in a network effect, right? So one of the proponents or people who really believe that, Bitcoin is going to be the be-all and end-all network is that it has, millions of people, presumably through wallets and also through the miners and other parties that are supporting this network. And that network effect, just like with the internet, creates a degree of trust that people can rely on over time. And as more people get involved, it becomes increasingly hard to, effectuate certain types of attacks, which also over time leads to just a layer of human trust, not just a computational trust, but a human trust in the network. I mean, do you think that that's valid, or is that invalid?
I think that, like, the network effect increases the amount that you have to pay, but I do think that the amount that you have to pay does have to do with, like, the hashing power, because even if the social consensus is that, like, this fork was bad, that's not going to stop the protocol from choosing the longer, like, heavier fork if it is produced by an attacker who is willing to spend those resources.
Well, I would say there is some truth to it. I mean, if you have like a system that's supported by millions of people instead of just one person, you can be more sure that it's going to continue and function in the future. So if this is what you were saying.
Yeah.
I think it's interesting to think how if you have a system where a sufficient number of disparate parties participate in it, even in cases where the security assumptions do break down, because, for instance, North Korea decides to spend $100 million, 51% attacking the Bitcoin blockchain, or whatever it is, because so many people are affected at once, you have very high incentives to coordinate and find a solution to the problem. It may not necessarily look like this.
Do you want to just provide a context for 51% attack? Just to make sure everyone...
So the Bitcoin system, it itself essentially says whoever destroys the most electricity is I should say the chain that destroyed the most electricity is the one that's defined by the protocol to be the correct one. And then he set up some economic incentives so that the process of destroying that electricity to create that chain happens to go and occur in a useful way that's very publicly visible, and the data that goes into that chain is publicly visible, which is why you can use it as a source of auditing. And it's such a good source of auditing, you can bootstrap all currency out of it, because every transaction is in that chain. Everyone can audit that everything was done right. And in the case of, say, this North Korea spends however many hundreds of millions of dollars to destroy the system, that's to say they go outspend everyone else. And by the definition of the protocol, now their chain is the valid chain, and everyone else's transactions suddenly no longer appear. And in reality, what would happen in that case is the much broader world of people who rely on this system would say, all right, we need to fix this. Maybe it's going to be some yucky hack, like I'm going to go sign a statement saying this is the right chain, North Korea's chain isn't. Or it might be something more sophisticated, like let's buy some more computing power and make it longer. Whatever it is, there's strong incentives to go fix it. And equally, that bar that's so high of destroying it in the first place, everyone's contributing a little bit of money to making it more secure. In every individual person, it's not necessarily that bad.
I think the bar to destroy it is actually excessively low. It's not high. You just need to hack essentially 10 servers, which are pool managers, and basically you don't need to spend a lot of money to have a 51% attack.
Well, I think this goes back to my point about fixing it. You're quite correct. Currently, you could temporarily hack 10 people and you would go and cause a lot of problems. But because Bitcoin is this public thing, the moment somebody did this would become very obvious. Oh, wait a second. Why are blocks getting produced that contain this information that should not be there? And literally what would happen is people would start getting out their phones and calling each other and fixing that problem because there's such strong incentives. And once that problem gets fixed, well, Now we've patched that very unfortunate hole that should not be there, but now we continue on the system which, yeah, we kind of showed it didn't work as well as we should, but it publicly failed, it was publicly fixed, and that's much more trustworthy than other systems which can privately fail, can privately be fixed, and nobody actually knows what happened.
Right, so a blockchain, at least the public blockchains, they develop a degree of utility, A, because they have public transparency, B, they have a high level of security, and C, if they get to scale, then they're supported by a large number of people, which over time can lead to a degree of trust. But I guess the question, beyond just public blockchains, which are clear that they have are showing some utility and may have a wide range of applications, there's a lot of efforts to build private blockchains as well. So are we going to see a world where everything needs to be registered to a public blockchain, or are we going to see a world a lot like in the internet, where we have internet, but we also have internal intranet type networks? So I guess this is mostly directed towards you, Casey, because I think you might have something to say about that.
It certainly is our hypothesis that we will have a mix of both. I don't think that we will end up in a place, again, this is our hypothesis, but we don't think that we will end up in a place where there is one database in the whole world, one blockchain in the whole world. Data doesn't really work that way. As we've seen the Bitcoin blockchain grow, there is a direct correlation. Whether it's causation or not is kind of to be determined, but we've seen the number of nodes, full nodes running on the Bitcoin network sort of have a real close correlation to the size of the whole blockchain. Now, as that continues, the size of blockchains is a one-way ratchet, at least at this point. If scalability solutions are able to shard or take care of some of that, then we would be in a very different place. But that said, public blockchains are meant to be a permanent record. And so I don't think that all data, number one, needs to be permanent, even if it is distributed. And number two, I think that a lot of data can benefit from the transparency and verifiability increases that a blockchain style data management system would bring. So if you bring those two together, you reach our hypothesis, which is that we're going to have a wide variety of public and private blockchains.
And what do you see some of the applications for private blockchains?
There's a lot of applications, but generally where you need to have verifiability of business processes, you're going to have a real strong argument for reconceptualizing those processes onto a blockchain. Number one, even if it is within a distributed corporation, and most multinational corporations really effectively operate as distributed organizations rather than centralized organizations, that is going to be one major application. The other major application that I think we will see emerging over the course of the next year is where you have consortiums of businesses which need to coordinate as to business processes, that you will see private blockchains be utilized in those contexts.
And, it's important to mention how, as much as this notion of a blockchain has been popularized by Bitcoin, the actual data structure we're talking about of having data that links to other data in a historical record is being around for a very long time, and ways are even more advanced than Bitcoin itself. I mean, as an example, the program that manages the source code for Bitcoin itself, arguably Git, is some type of blockchain, in that you have changes to the software. Every change goes in a block that patches the previous change, and you just go and show this historical record going back. It's not monetary, but it shows a historical record that can be verified for integrity, and you can go and get that transparency, and it ends up, from sort of high-level computer science point of view, looking like a blockchain, and the consensus is maintained simply by, all right, do we trust Linus Torvalds' copy? Well, sure, but we can verify what's in it too. And that kind of meets, I think, the definition.
So let's just shift focus a little bit and just talk about kind of some of the different types of applications that are getting built. So maybe you could talk about Huntercoin a little bit and just talk about some of the non-purely financial applications for blockchains.
Well, one of the issues with, I would say, with mining Bitcoin and the other cryptocurrencies is you need, well, when it first started, you could mine with your CPU, but now you need hundreds of thousands of pounds worth of equipment to actually get any of the coins. So what we've done with Huntercoin is you can basically still mine it in the traditional sense, but 80% of the coins actually come from inside a virtual universe which takes place within the blockchain. Now Huntercoin is based on Namecoin, which allows you to store a name and some values in the chain. But with Huntercoin, what we have done is made it so those names are characters or avatars inside inside a virtual world in the blockchain. It's actually like a mini universe. So by playing this sort of very basic real-time strategy game, you can use your mind to actually get the coins with inside the game. And I mean, for me, I think that's like quite a step forward in creating like an alternate reality inside the blockchain. I mean, one of the advantages of it is, you can actually get the coins for paying like 600 hooks or something like that, which is the currency in Huntercoin, and create a few characters and then mine them yourself just on a standard computer.
So, and also you mentioned Namecoin, so
Yeah.
maybe just describe a little bit about what Namecoin is doing and kind of, I know the mission has shifted over time, but kind of what
Yeah.
the core idea of it was to be used for.
Yeah, the core idea of it was, well, as I said earlier, it's to store like a name with some values in the blockchain. So you could use it for, like, the original use case was for like a decentralized naming system, which if like we're all talking about making things decentralized, then decentralizing the internet, well, a major part of the internet, the domain name system part of it, is one step forward. So some other use cases for Namecoin are things like voting systems, stocks and shares, and identification systems. Like, for example, you could store your name in the blockchain, like Andrew, and then associate some values to it, like my email address, a Bitcoin address, and you could also use that same function to make Bitcoin addresses human readable, things like that, really.
Yeah, I mean, and I think Namecoin is definitely one of the most interesting projects. I mean, there's been a number of notable ones that have emerged on top of it. So people are using Namecoin as the back end for an online identity system.
Yeah.
There's one called OneName that's a notable example of that. There's also another project that's using it to create digital scarcity. They're allowing you to register digital artwork and create a first print and prove that this is the first print of a digital piece of artwork. That's called Monograph. There's another one in Europe called the Scribe that's doing something similar. I don't know which back-end blockchain. But the point being, I think Namecoin has been an early example and an early backbone for some non-financial applications, and even just pausing on the issue of DNS. I mean, the idea of having a truly censorless internet, I think has a lot of interesting applications, especially when you begin to look at how countries have been able to basically create walls around it. So I think
Just like it says here, one of the other advantages of Namecoin is it's actually merge mined with Bitcoin. So you can actually mine Bitcoin and Namecoin at the same time without using any extra hash power, and that was actually sort of, I think, one of the genius ideas of Satoshi Nakamoto, who actually came up with that actual concept.
Yeah, and I mean, and that's, I think, what Peter was talking about before, that it may be advantageous to, you can have a separate blockchain serving a separate purpose, and ultimately have it root back into the blockchain to add, I guess, a degree of security and verifiability, right?
I'll
That's fair.
Just for technical reasons, merge mining has some issues, but, you know, the basic principle, yes, I agree with.
So from the standpoint of applications, I think what Andrew already alluded to, I think the important thing is that all these platforms provide a really open transaction platform and layer. So if you think, for example, of a decentralized Uber, like somebody offering a ride, a driver, and a customer. So if you do this on one of these systems, an insurer could come along and service that during the time that this ride takes place with an insurance. So this is kind of maybe a really simple toy example, but I think shows and enlightens like what these systems could mean, in that they open up the whole back office of businesses and make it open to be serviced by anybody.
So another question, I guess, is just generally about smart contracts. I mean, what types of things beyond provenance are we generally just seeing in the ecosystem? What types of things can be built with smart contracts in the financial and also kind of non-financial settings? Silence.
One thing
Yeah.
we've been working on recently, and I think we'll be releasing this week, is, and this sort of follows on with the Namecoin discussion, we have seen in sort of cloud-based environments that distributed configuration management is actually a challenge across data centers. Within data centers, there's pretty well-established solutions for how to deal with this. One of the biggest of which is made by a company called CoreOS, and it's called etcd, E-T-C-D. And etcd works quite well. In fact, it works incredibly well within data centers. However, across data centers, it doesn't work very well. And also, it doesn't really have an access layer to get at the configurations that you're dealing with. So we've been reconceptualizing etcd, and we've called it etcb. And one of the reasons that we're doing that is when you look at blockchains, they work really well across data centers in a global environment, number one. And number two, if you use a blockchain with a smart contract backbone, then you can add access control layer to be able to add something to the configuration. And so while you can do that with other things, you can't do it necessarily in a completely verifiable way, which you could do with a smart contract backbone. So this is what one thing that you could do that's sort of non-financial. I think we have the next panel isn't about financial smart contracts, but outside the financial world, there's a lot of things which you could do which can bring increased transparency to a system.
One non-financial application that I'm very passionate about, but that no one really wants to hear about, is certificate revocation. So revoking certificates on the internet and in like real life is very, very difficult, because you kind of need to issue a revocation that somehow needs to like chase that certificate down, so that anyone who sees the certificate also sees the revocation.
Vlad, could you just take a step back, give a little more context about what you mean by a certificate, just so.
So a certificate is like
An SSL certificate? Or?
yeah, no, but there's more than just SSL certificates. The certificate is like some like authority authenticates some information about some entity and creates a certificate that claims that yes, this IP address really belongs to this company, or you can have like different certificates for different purposes, and the certificate is like a digitally signed form. And if that authority were to like say discover that really that company doesn't exist at that IP address, they have to revoke that certificate, or else people can be misled. And on a blockchain, if you place certificates on a blockchain, you can revoke them also on the blockchain, when you authenticate the blockchain, you are guaranteed to see a revocation if there is one. And that's something that like hasn't existed actually before blockchains.
Yeah, and if that gets implemented, that would drastically increase the security of, or maybe not drastically, but it would definitely increase the security of just traditional internet, which it would be a very powerful application. You want to?
I believe that's possible with Namecoin as well.
I could actually probably give a very concrete example, which is, your passport. Every passport has an individual number, and they do maintain revocation lists of what passport numbers have been revoked. And in theory, those revocation lists are supposed to be distributed around the world to the various agencies that would go and check passports, border controls especially. And one of the issues you have is that, if you're a border control in, say, Canada, and you're checking Australian passport, and you're pretty sure you have the most up-to-date revocation list, the real issue you have is it's quite possible for somewhere in that process from the Australian revocation master list to you, for you to end up getting a different list than someone else. And that may be because somebody's deliberately trying to go set up a situation where you're going to let someone into the country as an expired passport. And in the case of a passport, that's a scenario where, because it's very centralized, it's fairly easy to say, all right, we're going to go call them up for the latest revocation list every day. We'll authenticate by this phone number and so on. But when you map that kind of analogy to something like a computer environment where you have hundreds of thousands of revocations, they're constantly happening because people are swapping things in and out. This is distributed over a very wide network. These kind of challenges that are analogous become harder and harder and harder, especially when the revocations may not be coming from a single source. And you want to be absolutely sure you really are seeing the same revocations as everyone else. In a passport, all that happens is someone can't travel. In a digital system, it may be this lack of revocation means a direct compromise. So there's a lot of incentive to make sure that these lists are maintained and distributed. And what do consensus blockchains do? Well, they come to consensus.
So, I think we could probably talk about this for, did you want to add something else?
Yes, so this sort of technology might require some cryptography to make sure that basically you can verify that the password was revoked, but you wouldn't be able to get all these numbers from the database. And I wanted to mention that the same can be done for banknote numbers. It's known, for example, that criminal production of banknotes have frequently identical serial numbers, so they could be blacklisted, and the list could be distributed to the people. And also, there are some limitations in this technology. For example, in the UK, there is a lot of genuine passports given to criminals, and one of the terrorists, for example, in the UK had 2 British passports with different names, which were authentic, but he just pretexted and obtained them.
So I don't know if anybody has any questions. I think we're just gonna, we could talk about this forever, but if you guys have any questions, we'd be happy as a panel to answer them the best that we can.
And ideally, the questions would be addressed so that we can have more than one question. Unless there's no questions, in which case they don't need to be addressed.
All right, well, if there's no questions, then, I guess we'll move on to the next